Where's the clicker thingy? Here, right here. Okay, perfect. Hey everyone, good afternoon. My name is Faye. Welcome to the lightning talk, how to productionize a sub-agents for LLM post-training. I'm a tech lead at Pinterest Growth AI Applications. Excited to be here with y'all today. So as we know that the Cloud Code or any code gen tool has accelerated the software development from zero to production ready in a matter of days. But how about machine learning and AI engineering? What does the model training now looks like? Because no matter what you're building, if it's an agentic CRM tool or threat hunting security products, you want your model to be a line of what we call good, meaning the right reasoning, the right time for tool calling, and the right persona to answer a customer's question. So before Cloud Code, we call it BC, our model training process looks like this. It's a giant linear process where you first define what's your data look like with cleaning, JSON parquet, and then download your Hugging Face models with hyperparameters, choosing your LoRa, QLoRa, full fine-tuning process, and define your loss function and reward config. And then you start the big eval development restart loop. And once you have productionize your model, oftentimes you get user preference data, and you use reinforcement learning for DPO, PPO type of training. So all of that is incredibly manual and takes 4 to 6 weeks. Now introducing our new workflow, which just takes about a week using Cloud Code. We effectively break down the model generation of the training data using Cloud Code SQL ingestion and also training parameters. And all of that task has been parallelized using sub-agent structure. Now, for full transparency, we did explore other agent architects as well. So right now, off the box, Claude does support sub-agents and agent teams, also known as agent swarms. The biggest difference is for sub-agents, you essentially communicate with the sub-agents only via your main agent, and you report back once the task is done. But for the swarm mode, the agents share a task list, and then each teammate communicate with each other and check each other's work until you move to the next stage. So one might say, hey, the second method works better, right? Because it sounds way more advanced, but not necessarily true for model post-training. This is because we quickly found out 2 bottlenecks. Number one is context limitation. As you imagine, each model keeps giving other models the results of its own task, and the context window quickly expands exponentially. And number 2 is the rigidness of the orchestration. So right now, Cloud Code doesn't support a dynamic scaling, meaning you will quickly run into what we call the hot celebrity problem in system design, where one of the agents become incredibly busy and bottled down with the task, and there's no way to easily scale sub-agents among that. So we started our journey with a sub-agent structure. And for a side note, if Opus is way too expensive, I would highly recommend Minimax 2.5. It's a fraction of the cost of 0.27 cents on the dollar here. And also, it's trained on PARL, preference alignment, reinforcement learning. It essentially kind of solved the second problem of the swarm agent from Claude. It knows when to dynamically scale your sub-agent when it needs to. So in production, we also quickly realized there are a few patterns that coding agent for post-training often fail. Number one is spec drift, meaning throughout the iteration of training, eval, redo, the model main framework often forget what the success metrics looks like. And the second is data distribution. Arguably, this is the biggest bottleneck to the success training of the model, where you have very uneven data representation bias, and that's what leads to a training and loss graph over here. And the third is memory collapse. Once you started to train your models after 20, 30 to 100 epochs, the model essentially forgot how to get the right memory config from previous time, and it started to hallucinate. And lastly, tool misuse. This has become less a problem, I think, this year, just because as industries ourselves, we learn how to better define tool use for agents, but it's still something to watch out for. I wanted to provide some fixes that have improved the post-training mechanism. Number one is reinforce the agent orchestration with Agent SDK. The Agent SDK from Anthropic is an open source agent orchestration tool. You essentially can define your full loop beyond just the graph, the chains. It also has the nice hook mechanism where you can gate each model output from your agents as a machine-readable artifact. For example, for our data processing, we will have agents write their own dataset report, the representation of each country, each user, and etc. In the end, we also have gated decision to reject or ship instead of doing the linear process that we previously have. The two tips I want to quickly share here. Number one is the structured skills.md. Now, we moved from a natural language style MD to more structured perspective. This is because we quickly realized the better instruction you give the agent itself. For example, you want to kickstart on the hyperparameter that you want to choose, the better the agent align with the process. And if you don't know where to start, I highly recommend the MS model that is open source to teach agents how to train your LLMs. And the second big unlock we see is actually implementing what we call the tool calling 2.0, tool calling 2.0. Essentially, instead of giving agent just back and forth information, how is the data looking? Is it not good enough? Let me redo it. We essentially giving the agent capability to write its own code to solve its question. So the traditional path looks like this. You have 5 requests, 5 response. But just letting agent handle you 1 response with the script and then have the loop until it checks its own work drastically reduce 70 to 50% of the token consumption. Now, tips number 2 is customize your agent memory. We all know how the Cloud Code SDK agent memory work, where you have the procedural memory and your MD, and also the episodic memory for each training episode. So what we did differently is, because not all the training log is helpful for us, we developed our own memory API tool, meaning we add our own pruning and compression logic on the server side to decide what is useful to store. And then we also put a very lightweight reward model for the agents of what kind of memory gets written here. Now, I do want to claim that it is working in our production now, but very likely in the next 3 to 6 months, this is going to become tech debt. It depends on how fast our agent evolves. And in the end, I want to leave you all like kind of an open question thought. What happens for long horizon development memory? Without long horizon memory, model often collapse, and then we see beyond Cloud Code what Cursor is doing right now. It's essentially using a hybrid retrieval semantic search and also compile its constant resynced memory via Merkle tree, which is the backbone of how cryptocurrency, for example, Ethereum is created. And also for open source tool Leda, it's essentially using the agent blocked memory from archive retrieval and also on top of vector database. So the 2 papers I read this month I thought it was quite interesting is number 1, essentially treat memory as a learned memory with the agent and answer using PPO and how to answer using GRPO. And then very lastly, a very interesting deep dive on the infra side, where this paper condensed the memory into hot domain and cold storage via MCP. So thank you for the time, and I'll be down there if anyone has any questions.